Hello and welcome to MasterTech. In this program we'll be discussing the 42LE Transaxle. This Transaxle, new in the 1993 model year, is used in the Chrysler Concorde, Dodge Intrepid, Eagle Vision, and Chrysler New Yorker. As many of you already know, the 42LE designation identifies the Transaxle. The first number, 4, represents the number of forward speeds. The second number, 2, indicates that it's a heavy-duty transaxle. The letter L indicates that the transaxle is mounted lengthwise or north and south in the vehicle. The letter E designates an electronically controlled transaxle. The purpose of this program is to acquaint you with the 42LE Transaxle's electronic control system and its diagnosis. In this program, we will discuss the transmission control module and its inputs and outputs. We'll also look at diagnostics and testing using the DRB2 scan tool and 42LE Transaxle Diagnostic Procedures Manual. And we'll introduce you to a new procedure, reprogramming the transmission control module. Let's begin by looking at the brain of the 42LE Transaxle, the transmission control module. The transmission control module, or TCM, is located on the left fender behind the battery. It's called a transmission control module because only the transmission is electronically controlled, not the differential. There are a number of advantages to using a TCM. The TCM continuously updates and stores clutch apply and release rates and clutch fill volumes. This capability is referred to as adaptive memory. Adaptive memory provides good shift quality for the life of the transaxle. The TCM also has a feature known as Quick Learn. Quick Learn speeds up the learning process of the TCM for better shifting. You would use Quick Learn after replacing a transaxle, torque converter clutch, or TCM. The TCM also has the ability to monitor the electronic control system for malfunctions. When something goes wrong with any of the major electronic circuits, a 2-digit numeric diagnostic trouble code is put into memory. In addition to sensing electrical malfunctions, the TCM can also detect some hydraulic and mechanical malfunctions. These also produce diagnostic trouble codes. Another feature of the TCM is the ability to protect the transaxle from potentially hazardous operation by shutting down the electronic controls and putting the transaxle in limp-in or default mode. When in limp-in mode, all 4 solenoids are de-energized and the transaxle enters second gear when in any forward drive gear. Reverse, park, and neutral also operate in limp-in mode. This is possible because second, reverse, park, and neutral are hydraulically controlled. When the ignition is turned off and then on again, the TCM resets itself to operate normally until it senses the fault again. The TCM has 4 levels of memory: ignition cycle memory, which is lost when the ignition is turned off; battery-backed memory, which is maintained as long as the battery is not disconnected; electrically erasable memory, which is updated periodically and not lost even if the battery is disconnected; and hard memory, the original memory programmed into the TCM. The TCM is provided battery voltage at all times, even when the ignition is turned off. When the ignition is turned to the off or column unlock position from the column lock position, the TCM performs a start routine, checking incoming voltage, critical inputs, and memory circuits before it powers up the system. The TCM also performs a self-check to determine if the TCM, transmission control relay, and the solenoid pack are performing properly. If the self-check is okay, the TCM sends battery voltage to the transmission control relay, also known as the ETAX relay. The relay closes, sending battery voltage to the solenoid pack to power the solenoids and pressure switches. If the self-check fails, the TCM sets the appropriate diagnostic trouble code and the system goes into limp-in, de-energizing the transmission control relay and preventing the solenoids from functioning. When the ignition switch is turned off, the TCM goes through a shutdown routine. During the shutdown routine, the TCM remains in an awake mode for the first 20 minutes and continues to monitor certain functions. After 20 minutes, the TCM switches into a sleep mode, using a small amount of current for its battery-backed memory, also called keep-alive memory. Battery-backed memory is where diagnostic trouble codes and adaptive memory are stored. Diagnostic trouble codes aid in diagnosis. Adaptive memory stores clutch apply and release rates and clutch fill volumes. Why do you need to know about the shutdown routine? If you're performing an ignition off-draw test while the TCM is in the awake mode, it will affect the amount of current flowing through the test light or ammeter. If you disconnect the TCM from direct battery voltage, the most current values stored in battery-backed memory are lost. In this case, when you reconnect the battery, clutch fill volumes, which have been periodically stored in electrically erasable memory, are substituted. It then takes about 10 shifts to relearn clutch apply and release rates. The TCM has 3 grounds: a case ground to a bracket securing the module, a power ground wire, and a signal ground wire to the left front frame rail. The signal ground minimizes signal noise from the sensor circuits. The TCM is connected to the C2D bus. This connection provides a way to communicate with other vehicle control systems as well as the scan tool. The TCM receives information from several inputs to make decisions on how the transaxle functions. The TCM uses these inputs to determine when to upshift, downshift, and when to engage and disengage the torque converter clutch. It also uses the inputs to control shift quality. We will discuss TCM inputs and outputs in the next section, but let's try a review question first. If you are checking ignition off draw, how long do you need to wait before the TCM goes into sleep mode? A, 5 minutes, B, 10 minutes, or C, 20 minutes? The answer is C. The TCM remains in an awake mode for 20 minutes. It then enters the sleep mode. So you would have to wait 20 minutes before doing an ignition off draw test. The transmission control module uses several inputs and outputs. They're directly wired to the TCM or received indirectly over the C2D bus. Direct inputs are battery feed, ignition run signal, cranking signal, throttle position sensor signal, engine speed signal or DIS crank sensor signal, input speed signal, output speed signal, manual valve lever position sensor signal, and pressure switches. Inputs received over the C2D bus are target idle speed, coolant temperature, battery temperature, brake switch on-off, engine and body identification, engine speed, speed control switch on-off, and manifold absolute pressure sensor. There is also a torque reduction confirmation on vehicles equipped with the 3.5-liter engine. Direct outputs are the transmission control relay, solenoid pack, and vehicle speed signal. There is also a torque management signal on vehicles equipped with the 3.5-liter engine. Indirect outputs are shift indicator position to the body control module and communication with the scan tool for diagnostics. The first 2 direct inputs, battery feed and ignition run signal, were discussed earlier. The other direct inputs include the cranking signal from the ignition switch, which is used by a TCM to determine when the engine is being cranked. A throttle position sensor signal is used by the TCM to help determine shift points and shift quality. The throttle position sensor uses a 5-volt input from the powertrain control module's regulated power supply and a common sensor return wire that is connected to both the TCM and powertrain control module, or PCM. The engine speed signal comes directly from the crankshaft position sensor to the TCM. The crankshaft position sensor uses an 8 to 9.5 volt regulated power supply that is provided by the powertrain control module and a common sensor return wire to both the TCM and powertrain control module. The engine speed signal is sent directly to the TCM to avoid any time delay that can occur when the engine speed signal is sent over the bus. The input speed signal is provided by the input speed sensor, located on the driver's side of the transaxle case close to the bell housing. This sensor allows the TCM to calculate transmission input RPM. The output speed signal is provided by the output speed sensor, located on the driver's side of the transaxle near the transfer chain cover. The TCM compares output speed with input speed to detect clutch ratio and slippage. Output speed is also compared to the throttle position sensor signal to determine shift points. In addition, output speed is used for vehicle speed by the body control module and powertrain control module. The TCM determines what gear range was selected by the driver by monitoring the input signal from the manual valve lever position sensor, or MVLPS. It uses this information to determine what gear range and shift pattern to use. The sensor also operates the backup lamps and the starter relay. It does not allow starter engagement in any position other than park or neutral. This manual valve lever position sensor is mounted on the valve body and is submerged in transmission fluid. The connector is found on the passenger side of the transaxle. The last three direct inputs are the three pressure switches in the solenoid pack. These tell the TCM if there is hydraulic pressure in each of the three circuits. This information verifies that the solenoids are operating correctly, and from this information, the TCM can determine what gear the transaxle is in. Each switch opens as pressure falls to about 11 psi. At this point, the TCM senses battery voltage. Each switch closes as pressure rises to about 23 psi. At this point, the TCM senses zero voltage. The low reverse pressure switch, 2-4 pressure switch, and overdrive pressure switch are all located in the solenoid pack mounted to the valve body. Those were the direct inputs. Now, let's look at the inputs to the TCM received over the C2D bus. Target idle speed is the idle speed the powertrain control module wants to maintain. This information is sent to the TCM and used to determine at what RPM closed throttle idle is occurring. The main temperature inputs to the TCM are engine coolant temperature and battery temperature. The TCM uses temperature information to improve shifting in all temperatures. Information on how temperature affects shift schedules is provided in the reference book. Temperature inputs are also used in decisions to engage and disengage the torque converter clutch. The TCM prevents the torque converter clutch from engaging until the engine warms up to normal operating temperature. The TCM engages the torque converter clutch to improve cooling in an overheat condition. The brake switch on-off signal is used as an input to disengage the torque converter clutch when the brakes are applied. The engine size and body identification codes are stored in the powertrain control module and sent to the TCM over the bus so that the TCM can determine which shift schedule to use. Engine speed input from the powertrain control module is used to verify that the direct input engine speed signal is correct. The speed control on-off switch affects the point at which the torque converter clutch engages or disengages and the time at which kickdown shifts occur. The manifold absolute pressure sensor calculates engine load and output torque to the input shaft. The TCM uses this input to modify shifting and reduce 3/4 shift hunting on grades. On vehicles equipped with a 3.5-liter engine, the powertrain control module sends a torque reduction confirmation to the TCM based on a torque management signal from the TCM. Those were the inputs to the TCM. The TCM takes the input information, evaluates it, then uses it to control 4 direct outputs: the transmission control relay, solenoid pack, vehicle speed signal, and the torque management signal. The transmission control relay is located in the power distribution center. It provides battery voltage to the solenoids and switches of the solenoid pack in the transmission sump. When the TCM receives an ignition run signal from the ignition switch, it performs circuit checks and a relay check. If there are no problems, the TCM activates the transmission control relay. When the transmission control relay is activated, battery voltage is provided to the solenoid pack. The TCM monitors relay voltage and applied battery voltage. If the TCM sees a problem in the system, it turns off power feed to the relay. The solenoid pack contains 4 solenoids that control the hydraulic circuits in the transaxle. The TCM turns the solenoids on and off by completing the solenoid ground circuits. Another direct output, the vehicle speed signal, is sent directly to the powertrain control module. The vehicle speed signal is based on information from the output speed sensor. The powertrain control module sends the vehicle speed signal over the C2D bus to the body control module, which sends it to the instrument cluster. On 3.5-liter engines only, the TCM sends a torque management request signal directly to the powertrain control module during high-speed 1-2, 2-3, 4-2, and 3-1 shifts. This controls the amount of torque to the 2-4 and OD clutches during application. The powertrain control module uses the torque management request signal to shut off some fuel injectors and slightly retard the ignition timing to control torque during certain shift sequences. There are only 2 indirect outputs from the TCM. The first is the shift lever position signal, which is sent over the C2D bus to the body control module and then to the electronic shift indicator display in the instrument cluster. The second indirect output is the information the TCM sends over the C2D bus that can be accessed by the scan tool. Those are the TCM inputs and outputs. You should also be familiar with the Transaxle electronic control system wiring connectors. There are 4 connectors on the transaxle itself. The manual valve lever position sensor uses a 10-way connector. The output and input speed sensors each use 2-way connectors. The solenoid pack uses an 8-way connector for the 4 solenoids and 3 pressure switches. The additional pin provides battery voltage to the solenoid pack. This connector should never be removed for diagnosis. If diagnosis is required, the entire valve body should be removed. A 60-way connector is used at the TCM. There is also an 8-way and a 12-way connector on the passenger side bulkhead for diagnostic purposes. The reference book provides connector diagrams. Now, for our review question. What is the function of the transmission control relay? The answer is, the transmission control relay provides battery voltage to the solenoids and switches of the solenoid pack. Without this voltage, the transmission would go into limp-in mode.
"42LE transaxle problems may be caused by improper adjustments, hydraulic, mechanical, and electronic malfunctions, or poor engine performance. To narrow down the cause, a general diagnosis should always begin with information from the customer about the problem. The complaint should be defined as specifically as possible. The reference book includes questions that can be asked by the service advisor to isolate the problem. A road test is necessary if the customer has difficulty describing the condition. Whether or not you do a road test, always perform a visual inspection. Check for fluid leaks, proper fluid levels, and inspect the fluid for foaming or a burnt smell. Remember, there are two fluid sumps on the 42LE Transaxle, one for the transmission and one for the differential. If the fluid is okay, check the transmission electrical connectors to be sure they are not disconnected or damaged. The next step is to perform a shift lever status test. The accuracy of any diagnostic trouble code is doubtful unless this test is passed. You can diagnose trouble codes by using the 1993 42LE Transaxle Powertrain Diagnostic Procedures Manual. Remember, do not use diagnostic trouble codes to diagnose transaxle problems until after the shift lever status test has been performed and passed. This is a quick and easy way to verify that the shift lever positions are accurate. To perform the shift lever status test, connect the scan tool to the data link connector in the passenger compartment above the accelerator pedal. This is the only data link connector on the Concorde, Intrepid, Vision, and New Yorker. When the scan tool is connected, be sure the shift selector is in park and the ignition is turned on. With the scan tool, select Transmission, then E-Tax. The scan tool performs a bus test. If the bus is operational, the scan tool will scroll through to the E-Tax menu. To access shift lever status, go to State Displays, then to Monitors, and select Shift Lever. The scan tool screen displays the 4 manual valve lever position sensor circuits, whether they're open or closed, and the shift lever position. Move the shift lever to check each position. If the shift indicator matches the position displayed on the scan tool, you can check for diagnostic trouble codes. If the display did not match each gear position, perform test 4A, shift lever test. To perform a shift lever test, select System Tests. Then Shift Lever. With the shift lever in park, press Enter. Then move it to reverse and press Enter. Continue moving the shift lever as prompted until the test is complete. If you receive one of the error codes shown in test 5A, you are asked to perform a diagnostic test. If you receive the message Adjust Linkage, this procedure is provided in the service manual. Assuming that the shift lever test was passed, you can check for diagnostic trouble codes by returning to the E-Tax menu and selecting Read Faults. For example, we see that the scan tool displays code 57 and the reset counter displays 2. By the way, there are 2 kinds of diagnostic trouble codes, hard codes and intermittent codes. The reset counter displayed with the diagnostic trouble code is used to determine the type of code. The reset counter counts the number of times the vehicle has been started since the most current code was set. If the reset counter is less than 3, the code is a hard code. This means that the fault is there every time the control module checks that circuit or function. If the reset counter is more than 2, the code is intermittent. Intermittent codes are not there every time the circuit is checked. Since, in our example, the scan tool displayed a code 57 and the reset counter displayed 2, we will follow the diagnostic procedure for a hard fault. If the reset counter displayed a 3 or higher, test 2A would give you other directions. Let's check the diagnostic manual to see how to proceed. According to test 2A, to diagnose code 57, we should go to test 20D. Test 20D is the test for code 57, an open or shorted output speed sensor circuit. To start test 20D, we turn the ignition key off and disconnect the transmission control module. With the scan tool in ohmmeter mode, probe the output speed sensor circuit at pin 14 of the TCM 60-way connector for a short to ground. If the resistance is below 5 ohms, there is a short to ground. In this case, the resistance is above 5 ohms. So the next step is to check for an open circuit. With an external ohm meter, test between the sensor ground circuit, pin 13 of the 60-way connector, and the output speed sensor circuit, pin 14. If the resistance is below 300 or above 1200 ohms, the output speed sensor is defective or the circuit is open. If resistance is between 300 and 1200 ohms, the circuit is okay and the TCM should be replaced. In this case, the resistance is above 1200 ohms. The next step is to determine if the problem is in the wiring or in the sensor itself. Start by disconnecting the output speed sensor. Check the circuit from the output speed sensor to the TCM connector, pin 14. If the resistance is below 5 ohms, the circuit is okay. In this case, the circuit is okay. Finally, test the sensor ground circuit from the output speed sensor to TCM connector, pin 13. If the resistance is above 5 ohms, the circuit is open. In this case, the circuit is open, and the open should be located and repaired. That's an example of TCM diagnostics using the Diagnostic Procedures Manual. To perform other types of diagnostics, you should be familiar with the scan tool and the Mopar diagnostic system, if it's available. A fold-out at the beginning of the diagnostic manual provides a flowchart of scan tool functions related to the TCM. A simplified flowchart is also provided in the reference book. Let's take a look at some of the scan tool screens. The ETAX menu provides 5 major categories: system tests, read faults, state displays, actuator tests, and adjustments. System tests include tests for the shift lever, clutch, TRD link, and electronic shift selector. The shift lever test takes a closer look at shift lever position. This test is used when the shift lever status test is failed. The clutch test is used to check for slipping clutch assemblies when codes 52, 53, and 54 are displayed. The TRD link test is used to check the torque management circuit between the powertrain control module and TCM on vehicles equipped with a 3.5-liter engine. The electronic shift selector test checks the shift lever indicator circuit in the instrument panel. Those are the system tests. The ETAX menu also includes a read faults category, which provides diagnostic trouble codes, a reset counter, and a method to erase faults. The next category, ETAX states, provides module information, sensors, inputs, outputs, monitors, and custom display. Module information provides the version, the engine model number, and the TCM part number. Sensors provides throttle position values, various sensor and circuit voltage states, and transaxle temperature. Inputs, outputs includes pressure switch states, the last shift, for example 1 to 2, the gear the transaxle is currently in, the clutch pack being applied, and the shift indicator position. You can compare the displayed states of the switches to the normal pressure switch states provided in the reference book to help determine a problem electrical circuit or perhaps verify a hydraulic problem. Monitors provides RPM, the shift lever status test, memory monitor, and CVI monitor. RPM provides engine RPM, turbine RPM, output RPM, TPS, and gear. The shift lever status test checks the accuracy of the manual valve lever position sensor circuits, which tell the TCM what position the shift lever is in. When troubleshooting a no-start condition, remember that this sensor won't allow starter engagement unless the transmission is in park or neutral. So an inaccurate reading could cause a no start.
The memory monitor provides central processing unit information from the TCM. The CVI monitor is used to check clutch fill volumes. Clutch volume index is a number between 0 and 255 that is related to the volume of oil required to apply the clutch. Custom display allows you to select specific sensors that you would like to read on one screen. The next category in the ETACS menu is actuator tests. Actuator tests can be used to perform pressure tests on the hydraulic circuits of the transaxle by actuating each of the 4 solenoids. Caution: before selecting an actuator test, be sure the parking brake is set and the wheels are raised off the ground. Do not stand in front of the vehicle during this test or immediately after canceling it. The last category in the ETACS menu is adjustments, which includes some new features for 1993. Adjustments includes Reset EMCC, Battery Disconnect, Quick Learn, and Special Number 1. Reset EMCC, or resetting of the electronically modulated converter clutch, provides a break-in period for the torque converter clutch, eliminating erratic engagement for the first couple of miles after a TCM, transaxle, or torque converter has been replaced. Battery disconnect can be used to electronically disconnect the battery feed long enough for the TCM to clear diagnostic trouble codes and adaptive memory. This feature allows you to disconnect the battery feed to the TCM without losing battery feed to all vehicle components. The Quick Learn procedure allows the TCM to learn clutch fill volumes for better shifting after the TCM, transaxle, or torque converter has been replaced. Special Number 1 has been provided for updating purposes. This feature may be used in the future along with the TSB or recall notice. Reset EMCC and Quick Learn must be performed using the scan tool whenever the transaxle has been overhauled or the TCM, transaxle, or torque converter has been replaced. Then a road test must be performed. While on a road test, a specific procedure should be performed that will allow the TCM to relearn the necessary values to operate the transaxle with acceptable quality. Make 15 to 20 1-2, 2-3, 3-4 upshifts from a standing start to 45 miles per hour with a constant throttle opening of 20 to 25 degrees. This can be monitored with the scan tool set to read throttle position. When the road test is completed, check and verify that no diagnostic trouble codes have reappeared. This basic diagnostic information should help you when you face a 42LE diagnostic problem. Now for our review question. What test should be performed before reading diagnostic trouble codes? The answer is a shift lever status test, which compares the shift lever position with the manual valve lever position sensor switch combinations.
Beginning in the 1993 model year, it's possible to reprogram some transmission and powertrain control modules at the dealership, eliminating the need to remove and replace them when a software change is necessary. In this section, we'll explain this procedure, but first, let's take a look at the inside of a typical control module. A control module is made up of 5 basic components: a central processing unit, or CPU, read-only memory, or ROM, and random access memory, or RAM, input circuits, and output circuits. The central processing unit is the brain, which executes the outputs based on instructions from the inputs. The central processing unit accesses 2 different types of memory. The random access memory is used like a scratch pad to store temporary data and instructions, like diagnostic trouble codes and adaptive memory. Random access memory is lost when there is no voltage present at the control module. The read-only memory is permanent information used by the central processing unit to make decisions. It's not erased when voltage is lost, but it can be erased by other means. Types of erasable read-only memory chips used in control modules are ultraviolet or UV erasable and programmable, also known as a UV EEPROM, electrically erasable and programmable, also known as a EEPROM, and flash electrically erasable and programmable, also known as a flash EEPROM. Why is the flash memory chip significant? Instructions stored in the flash memory chip are updated occasionally. A TCM with a flash memory chip can be updated in the dealership instead of being removed and replaced with another module. The flash memory chip can be reprogrammed when a special voltage signal and programming instructions are received. In the case of Chrysler transmission and powertrain control modules, the dealership will be notified through a recall notice or TSB when reprogramming is necessary. After release of the recall notice or TSB, a dealership will receive a package containing a reprogramming cartridge. This cartridge contains the revised software. Also included in the package are instructions to follow while programming. To reprogram a TCM, you need the scan tool and OTC special tool package number CH5500. The package includes a flash programming adapter, TCM adapter harness, update labels, and a carrying case. The flash programming adapter is a voltage booster. The TCM adapter harness includes external battery connections to provide voltage to the flash programming power supply and scan tool. The harness also has wires that connect to the TCM, providing the special voltage and updated instructions from the flash programming adapter and cartridge. To program a flash memory chip, start by connecting the flash programming adapter to the scan tool. Then, connect the flash programming adapter to the TCM adapter harness. And install the flash programming cartridge into the scan tool. With the ignition off, disconnect the 60-way connector from the TCM and connect the adapter harness. You will have to move the battery to make this connection. Then connect the negative and positive battery leads on the TCM adapter harness to the battery, being sure to install the negative terminal first. The scan tool is powered up at this point, and the special voltage signal is applied to the TCM. The scan tool should display the copyright screen. After the scan tool sees the flash adapter, it will display the reprogramming screen. Pressing the Yes key starts the programming sequence. If the flash adapter is not detected, a display reads ETAX controller update, cartridge adapter not found. If this screen is displayed, verify that all connections are correct. Then restart the programming process. After pressing the Yes key, the scan tool reads Initializing. During this time, the scan tool is maintaining the special voltage signal, establishing communication with the control module, downloading the program to the control module, looking at the control module part number to assure it matches the update software, and erasing the program in the control module. After these steps have been completed, the scan tool reads Initialized and programming is taking place. The programming process takes about 40 seconds. After the scan tool has verified that the downloaded instructions were transferred correctly, the scan tool reads Programming complete. When programming is complete, the green LED is illuminated. When the TCM has been successfully updated, disconnect the scan tool and the flash programming equipment. Next, fill out and place a software update label on the TCM where it can be seen. After programming the flash memory chip, the control module is basically new. This means that the control module will have to learn to adapt to its new environment. This is accomplished by verifying communications with the controller, then performing some adjustments using the scan tool. To do this, select ETAX and the scan tool will perform a bus test. If the bus is operational, the scan tool will scroll through to the ETAX menu. The next step is to select adjustments. First, reset the torque converter clutch using Reset EMCC. Then, reset the clutch volume index values by actuating Quick Learn. Finally, perform a road test, making the upshifts described earlier, and verify that the transaxle is shifting and operating properly. Whenever an error screen occurs during reprogramming, the scan tool illuminates the red LED and beeps. If you encounter an error screen, be sure to retry the process 3 times before returning the cartridge or control module. For an explanation of error screens, go to this month's MasterTech reference book for a list of DRB2 scan tool error screens. Here's one more question before closing this month's MasterTech. What equipment is required to program a flash electrically erasable read-only memory chip? The answer is, a flash memory chip is reprogrammed with the scan tool, a special TCM adapter harness, and flash programming cartridge. Well, that wraps up another session of MasterTech. We've given you a basic understanding of 42LE electronics and diagnostics. For more information on the 42LE Transaxle, look for 2 new courses coming to a Chrysler Service Training Center near you. We'll look forward to seeing you next month when we'll be discussing Concorde, Intrepid, and Vision body electrical.
Revolutionary changes in automotive production and design have brought about an entirely new breed of vehicle. Dodge Intrepid, Chrysler Concorde, Eagle Vision, Jeep Grand Cherokee, and others all have extremely sophisticated electronic systems. In fact, it's fair to say that the computer chip is one of the most important operational parts in the vehicles of the 90s. Obviously, service today requires computer technology as advanced as the vehicles themselves. Looking under the hood or listening carefully during a test drive just isn't good enough. That's why Chrysler Corporation, in partnership with IBM, has developed the Mopar Diagnostic System. The MDS is a computer-based tool that will assist you technicians in diagnosing electronic problems by guiding them through automated diagnostic procedures and providing the technical information they'll need to make quality repairs. MDS is currently installed in over 1,800 Chrysler dealerships nationwide and expanding at the rate of 175 per month.
MDS, I think, is a tool ahead of its time, and that's the way that you need to approach it. If MDS comes into your dealership and you're looking for immediate profits or rewards from it, then all of a sudden you're going to think it's a disappointment. But MDS is our future. MDS is you have the ability to get trained on MDS right now and be ready for when these cars hit your store in 1993 late, in 1994, and 1995. It's kind of like building your technician team. If you go out there and you find a brilliant young man and you build on him and you train him, what do you have in the future? You have a brilliant young technician that's going to stay with you a long time. Philosophy of what we have. We've supported the Chrysler Apprentice Program. We have our 5th student about ready to go. 3 has graduated, and the 4th one will be out in the summer. But it took a long-term plan to do that, and MDS is the way that you have to approach MDS in the same way. Long-term plan. The technicians already are trained on it via going to Ontario, via all the updates and all the books that are out there available. It's kind of like when you get business, do you want to be prepared for it when you get it or after you get it? You know, this is the kind of thing that you've got to work with, and you've got to know that it's something that's going to make you a shining star in the future. Because it's the best library that anybody could possibly have. You could be a very poor organizer and have all the updated bulletins, have the latest to the latest bulletins that's coming out right now, and be a very poor organizer. So in that respect, MDS is already paying for itself if you fix one car with it. We've had some very good star moments with it already in just a short period, and we're just finding our way through it. The way you got to approach MDS is long-term. You can't approach it short-term and think it's a success. The ability to have an ally in repairing a car. I love the library aspect, and I think it's a great tool. But the best tool in this is to be able to pick up a phone, have somebody else be able to look at the same problem that you have and be able to talk to somebody about it. How many times have you been able to sit down in front of somebody and answer and tell them what your problem is and come up with the answer? All of a sudden you got the answer just by talking about it. Well, this man has the ability to pick it up and talk to somebody intelligent and talk about it, as well as he's looking at the same problem you are. So the aspect of being able to communicate with somebody and them to see the same thing you are has got to be the best tool about MDS.
It seems to have worked really well with us. It gives everybody a good insight of what the dealership's all about. The place has been here for right around 50 years. Mr. Berger's been in the Dodge business. It gives them the feeling that if they have a problem, we're going to be here. We're not going to run off and hide in the woods somewhere, and they can rely on that. They seem to be, it has a real positive effect in that way, I think. I think it's absolutely excellent. It really lets us connect with the car and communicate it with it. We have been able to do that for some time with the DRB2, which is a much smaller handheld device, but now we can incorporate the DRB2 with the MDS and utilize both of them. We can also, if we have a car that acts up once in a while, but it isn't going to do it sitting here running, we can program the small box as a data recorder, go drive the car. When this thing happens, you hit any button on the screen and it will start recording data, just like a flight recorder, so that we can come back and download that into the MDS and bring all of this graphic up on the screen and see what glitched, what caused this problem to happen. Did one of the sensors go blank momentarily? Did one of the injector drivers shut down momentarily? What really happened? And it will tell you definitely what started this malfunction.
It's a brand new machine for us, so it's a little difficult for me to tell you exactly what it's going to do as far as diagnostics goes, but I know that in the future it's going to help immensely on the problem cars that we might have, where the engineers can get involved with us on this, because a lot of times sometimes we'll get stumped, and this will help us out tremendously. Now, I don't think that anybody in the future is going to be able to go without it, any dealership.
In the years to come, this thing is going to be so valuable. The MDS is going to be so valuable that it's not going to be able, you're not going to be able to have it, not have it. It's full of information that it's going to have to be used, and it's going to be there. In today's day and age with cars, the way they are, you got to have that information. You got to have that right there on hand, so you don't have to spend hours on hours looking for some information that you don't know. And it's right there in that machine.
By providing faster, more accurate repair information, MDS will help boost your dealership's Customer One efforts and turn star moments into opportunities for your service department to shine. To obtain more information or to sign up for this exciting new product, call your Service Zone office today.